Hello, everybody. This is another recording that will show the performance of G3S in terms of solution space and solution finding into a very, very large search space, plus the what I call complexity decay. So I have here a number of CNF files that are actually building today's demo, and I will introduce you each individual batch of files. So the batch A is represents formula of 1,000 variables and 3,300 clauses. Let's look at one of them. And they're regular CNF in the max format. And probably you already know what that means. And what you notice, actually, they're 3-sat. This is a 3-sat formula, and so are all of them. So this is one commonality among the batches. So the next batch, the batch B, increases the formula size by 10. So instead of 1,000 variables, it has 10,000 variables and 33,000 clauses. Let's look at one of them. This is one of them, and the first. And they're different. Let's check another one, the next one, and put them side by side. Side by side. Okay. Where are you? Here. So yeah, they're all different, but they have similarities, and I would call this there are distinctive patterns that can be noticed. The next batch, the batch C, is going is coming with 100,000 variables and 330,000 clauses. And another similarity that you see here is the fact that the ratio between clauses and variables is always the same. However, the search space grows exponentially from batch to batch. And that's a lot. Now, the batch D, so let's see one of the C files. Of course, it takes longer because it has much more clauses in it, 10 times more clauses in it. And this one, as I said, 330,000 clauses. Now, let's, and then let me finish first. Batch D has 1 million variables and 3.3 million clauses, and batch E with 10 million variables and 33 million clauses. So what is the point of all this? First of all, you will probably see during this video that while the formula complexity grows exponentially, the execution complexity of G3S decreases. That's weird, right? It should increase. No, it doesn't, because it's using the patterns and figuring out ways of making more efficient the next batch from batch to batch, making the resolution more effective. And that's one of the particularities of G3S. Now, I will just show you one single of them, one of the A's formula, how this how the solution looks like. But before that, the G3S is assessing the local machine, and I will talk about this very soon. And once this step is done, okay, So the formula has been solved, and this is one of the solutions. Probably there are more. And let's pick another one and see how it goes. Yeah, it goes fast. So these files are actually the smallest ones, the A batch, as I said, with 1,000 variables. Now, later on, I will no longer use that verbose mode, but and I will run them all and see how fast does this goes. Okay, so batch A was almost immediately solved, and the columns here represent the following. This is obviously the name of the file containing the formula, number of variables, number of clauses in the formula. If a solution has been found and satisfiable is printed out, then the wall clock representing the raw time in seconds to find a solution, and then the order of complexity, which obviously is in terms of number of variables. So this is n to the 2.18, and is measured based on the number of variable hits per second. How many variables could be touched in a second? And to look at the performance of my computer, actually you can see it here. It's let's watch it. So this is a Intel i7 with 3.6 gigahertz and 16 logical processors with 8 cores, and the peak speed of roughly 4.6 gigahertz. And as you can see, is fully loaded as we speak. So the first of the batch B has been solved with 10,000 clauses in order of complexity of n, so 10,000 to the 2.36. Now, from this point on, while the complexity increases, the file complexity increases, also the raw time will increase. So this particular run for all the 50 files, 50 formula, will take probably several hours. So I will not make you watch the screen for several hours, but I will pause it and come back for a checkup once in a while. So until then, I will let the batch be run and come back once this is done. As you can see, already 3 of them are done. I'll be back once batch C is started. So be back soon. Okay, I'm back. So the batch B is done. Batch B was done in about 6 minutes, as I can see, starting 11:26 and until 11:32. Now the batch C started. As you'll notice, I ran this benchmark before, and I decided to record it. And I know how long it takes for 100,000 variables to find a solution within the space. And the difference in, probably it's useless to explain you that, but the difference between 2 to the 10,000 and as the search space for the batch B is one with 3,000 zeros or a 2 with 3,000 zeros afterwards, and that's huge. I don't know of anything other than states to be enumerated within such a large with such a large number, and obviously 2 to the 100,000, which is batch C, would have another 0, so 30,000 zeros long search space with 30,000 zero. afterwards, and that's huge. And you're probably asking yourself, how do I do this? How is G3S doing that? The white paper explaining the logical part of the algorithm, the mathematical part, is on my LinkedIn account and on q-dss LinkedIn account as well. But there are also an artificial intelligence part in it, and also a genetic evolutionary part. So G3 has three different parts working together in order to go through that humongous search space and find the solution. Not saying it's one only solution, but there are probably more. Now, the next question is how do I get this formula? I am using a public 3-sat or sat formula generator, and it took a while to produce the 50 files, especially that the 10 million here, let's take a look on these. The 10 million variables formula has about 1 gigabyte file, and let's really take a look on one of them and see. It's gonna take a while to load it. And they took I don't know, maybe 3 days all in all to be produced by the generator. It's a long process. Now let's see how the computer behaves. As you can, maybe you can hear it, and the fans are running wild because the temperature in the processor is went up to 90 some degrees Celsius. Yeah, so it's fully loaded. The GPU is not much in use. I mean, 10% here, although I'm not sure which one of these are real. In fact, all the computations G3S is doing are not using the GPU, the graphic unit of my computer at all. But I am planning to implement that as well. So, okay, this one hasn't loaded yet. It's a very, very large file. Now, until it loads. Okay. I know that the 100,000 variables, so batch C, I know how long it takes per formula to be solved. But let's take a look a little bit until this formula is loaded. Let's take a look a bit at the differences in complexity. So let's assume the 100,000 would go on the same complexity, will be solved on the same roughly same complexity as the batch B. So assuming n to the, so let's say n is 100,000, okay, to the, what would be the average here? I would say something like 2.20 something, 25, 2.25. Okay, that would be, I would need that many hits and touches of variables, and divided by the number of the power of the computer, basically 43 million hits per second. Let's divide this and see how many seconds it's supposed to. Okay, it should take around, what is this, an hour and a half, roughly. Okay, if the same complexity will be kept. And we'll see actually how this goes once the first formula is being solved, the first formula in the batch C. So let me wipe this out, and I will pause it until the first result of the first C batch formula is found, and I'll be back. All right, I'm back. So the first in the C batch, the first formula has been solved, and it took roughly 15 to 1600 seconds. So not quite the 4000 that we were looking at when we calculated. So um, it shows a certain decrease in complexity, but that decrease in complexity will be more visible once we reach 1 million variables, namely the D batch. And until then, I will pause and come back to check in once in a while. So until then, stay safe. I'm back. So the second formula of the C batch is done. Is done for a while now. Actually, I think the third one will come up soon. Now, I wanted to show you how a 10 million formula, three sat formula looks like, because the file has loaded. So, yeah, not much to see. You know how a Dmax format looks like, of a CNF looks like. So, this is what is going to be solved by the solver when the time comes. Speaking of which, I'll say that if for a 100,000 inputs variables, it took like roughly half an hour, let's say. We'll see how long it takes to figure out a solution in a 1 million, in the 1 million batch, the next batch, and later on in the 10 million inputs batch. So until then, I'll stay silent and be back soon. So I'm back. It looks that we reached almost half of the C batch with 100,000 variables, and the order of complexity seem pretty constant, like around n to the 2.16, 18, so 2.6, 2.17, and since I'm running these benchmarks and recording them too, you might ask yourself, why am I doing this? The explanation is simple. I've seen results published on different sites, papers, and so on, but they are just like, let me call them dry results. This way you can see how those results are obtained real life in real time. So yeah, we are at the number 5 in the C batch, and still to come. So I'll probably not hop in until the end of the C batch. So talk to you later. Hi there, I'm back. So it looks that we are reaching the very last one of the C batch. 100,000 variables. And so far, the order of complexity doesn't go beyond, let me see, n to the 2.18. We'll see what the last one will do. However, as a challenge, how is this going to be compared with quantum? What if we have a quantum computer that has 100,000 qubits? I don't know. Maybe it's gonna go faster than 1500 seconds or 1800 seconds. 19. Wow, that's a big one. Okay, we'll see. Anyways, the largest quantum computer, as far as I know, has 433 qubits. That means 433 Boolean variables. Okay, without jumping into any conclusions, we'll check this later once the 1 million variables formula come into place. So far, it looks like the C batch, it's going on a lesser complexity than the B batch, this one. And even if you don't calculate, I think it is visible. Anyway, I'll be back once the first of the D batch has finished, the first formula of the D batch. Until then, take care. Hello, I'm back. I'm back, and it looks like the D batch started already. 4 of the formula have been solved. The runtime, the raw time, is very close to the previous batch, the C batch, in the range of 16, 17, 1800 seconds, so half an hour, while the search space grew exponentially from 100,000 variables up to 1 million variables and 33 million clauses. While the order of complexity, if the runtime stood steady, the order of complexity decreased. As you can see here, it's quite a difference from n to the 2.15 to order of n to the under 2. So this is what I call the complexity decay. But we'll see at the end of this batch how it goes. Maybe it's increasing or decreasing, we don't know. Anyways, this is the batch D, as I said, 1 million clauses and 33 million, or sorry, 3.3 million clauses and 1 million variables per formula. And they all seem really close to the same complexity range order of execution. So let's see what how it goes until the end. Anyway, so far we started at 11:25 this morning, the 12th of April, and we are about 6.5 hours in the run, and we'll see for the rest. Until then, stay safe and talk to you soon. Bye bye. Hello again. Okay, batch D is done. Batch D, 1 million inputs, 3.3 million clauses. And it looks to me that the average order of complexity is around n to the 1.8, so less than n square, which is spectacular in my mind. For whoever understands the complexity of this knows that this kind of execution complexity is spectacular, and actually is much less than the previous run, which was n to the 2.16, 17, something like that. It doesn't matter. The wall clock for the entire run lies between 1,500 seconds and 1,900 seconds, which is really reasonable. However, the wall clock is not important because that is a matter of computation power, not of the complexity of the execution. So we started the 10 million inputs batch. Started like, let me see, about a half an hour ago. And since right now is 9:27 p.m., I think I'll be pausing this video and come back in the morning and see whatever results we'll have. Until then, stay safe and have a good one. Hello, everyone. It's almost 11 p.m. and the first result from the E batch came out. So, amazingly, 10 million variables formula has been solved in less than 2 hours with an order of complexity of n to the 164, much less than what it used to be before on the previous batch. Second second formula in the batch is being resolved right now, and my computer seems to hold on to the task. It's running smoothly, although the temperature seems to be pretty high. Doesn't matter. It's simply a desktop, and it is solving formulae of size 10 million variables and 33 million clauses. So I'll be reconnected in, I don't know, sometimes in the morning. By then, I'm hoping that more of those e-batch 10 million variables formula will be solved. But we'll see. So until the morning, stay safe and have a good one. Bye. Hello and good morning. It's Thursday, April 13th. So what happened overnight? It looks like the algorithm has very good results in terms of complexity for those 10 million variables and 33 million clauses formula, and it looks pretty consistent. So the runtime, although the runtime is not really important because that's machine dependent, but the runtime, it looks like under 2 hours constantly for each individual file, which is roughly 3.5 times larger than the previous batch. And yeah, for whoever understands computational complexity, knows that this kind of results are quite spectacular. So I will I will wait for the other four formula to be done, and I'll be back and take a look together at the charts that will be available from the will build together from the results we have. Until then, stay safe and goodbye. All right, folks, it looks like we reached the very last of the formulae I had in this benchmark, number 50. And to me, it looks like everything went the way we saw before. So that's the order of complexity that is dropping from one benchmark to the other, one batch files to the other. So I would say that this is a pattern. Maybe besides this one, the first one, the top one with the 1,000 variables, which is somehow different. I don't know why. Anyway, so far so good. And I may try to multiply by 10 again and generate a 100 million variables file. However, there is a problem, which is it looks like my computer has reached the max memory usage at this point. So thinking about the magnitude of the 33 million clauses, because that's the big punch in the formula. It takes 1 gigabyte, then probably next one of 100 million variables and 333 million. That's humongous. Anyway, clauses will be like at least 10 times larger if we look at the difference between the batch before and this one. 10, 11 times. So 11 gigabytes. I'm not sure how I will be able to handle that on this machine. In any case, I will be trying to do that and figure out a way to optimize the memory usage in the algorithm. Until then, I'll take a break again and talk to you a bit later. So stay safe. Until then, bye bye. All right, the benchmark is done. Finally, so it took me what a day and something from yesterday 11:25 till today at 16:10. Now, since I like to play so much with complexity, let's see the results and see how this went. Okay, that was a total of, let me check, a total of 103,000 seconds, as I say. That was the raw time, the duration. And let's insert a chart and see how this actually looked like. Okay, let me first wipe this out, because they stayed since they're here since my last intervention. Okay, so this is how the things went. And let's see the other axis. Okay, let's do that as a secondary axis. and the secondary axis, let's make it on reverse order. Okay. And see how this is supposed to be. Let's see. Okay. Good. And now let's see the trend line of the second axis and see how this goes. And let's display the equation on the chart. Okay. All right. Okay. Let's make a bigger font because I'm pretty sure that you cannot see much. So this is what it looks like in terms of execution. It is obvious that the execution the execution complexity decays from batch to batch. Besides the first one, as I said, it was really weird. The second one, not know what to say. The third batch, the fourth, and the fifth batch. And if we're making y equals 1, then we'll have a view about how many more samples we would need in order to reach O of n, so linear complexity. That would have been 1.34 53 53 divided by 0 0.0 what is that, 135, sorry, 0.0135. Okay, let's see. 99 samples. 99 samples, it's 100 samples. Let's round it up. And since we reached 10 power 7 variables, it means that we need 10 to the 12 variables. So 10 to the 12 variables in order to reach a linear complexity. 1,000 billion. That's quite a lot. Nobody reached 1 billion yet. So anyway, in my mind, this is very spectacular in terms of capabilities and in terms of the progress that q-dss did so far. And it's for viewers that really knows what this means, this should look spectacular. All right, that was the demo for yesterday and today. Sorry for the length of the demo. For me, it took what, a day and a half almost, and for you guys took like what, half an hour maybe, I don't know. So until my next demo, stay safe and goodbye.